Hey, quantitative reasoning. Today we're going to do conditional probability. So, in regular probability, we would say, what's the probability of drawing an ace? So, there are 4 aces in a deck of cards out of 52. So, we would say 4 out of 52, and then we would reduce it. In conditional probability, we are restricting the category. So maybe we say something like, what's the probability of drawing an ace given you've drawn a number bigger than 10? So the condition is that it is restricting the category from all the cards to just the ones bigger than 10. So in conditional probability, it's going to look like this. So where that bar is, you say the word given. So the probability of A given B means the probability of A and B. So that intersection is this part right here. It's the probability that both A and B are occurring. And the denominator is the probability that B has occurred. So whatever comes right there, that is always your denominator. So let's try a few of them. A single card is selected. Determine the probability that it is a club given it is black. So given it is black, that phrase goes with this script right here. So this means, what is the probability that your card is both a club and black? And given that it is a black card. So the half the deck is black, so that means 26 of the cards are black. All clubs are black, and there are 13 clubs in a deck of cards, and that would reduce to 1/2. A single card is selected. Determine the probability that it is a queen of hearts, given it is a red card. All right, so there's my given. So this is, what is the probability that you have the queen of hearts and that card is red? The denominator is the probability that you draw a red card. So half the deck is red, so that means my denominator is 26. The queen of hearts happens to be red, and there is only one of them. So that probability is 1/26. A single card is selected. Determine the probability. It is a 7 of spades, given it is a spade. So I want the probability that I have a 7 of spades divided by the probability that my card is a spade. So spades is one of your suits. There are 13 cards in each suit. There is only one 7 of spades, so that probability is 1/13. Determine the probability that the card is a queen of hearts, given it is black. So I want the probability that I have the queen of hearts, and that card is black, and the denominator is the total number of black cards in the deck. So half the cards are black, that's 26. The queen of hearts is a red card, so it cannot be both a queen of hearts and a black card at the same time. So there is no way that can happen. So this probability is 0. And the next ones. A family has 2 children. Assuming that boys and girls are equally likely, determine the probability the family has 2 girls. So if you were going to have 2 babies, you have the possible outcomes of having a girl and a boy and a girl, a boy and a boy, a girl and a girl. So when I have two babies, there are 4 possible outcomes here. This says, what is the probability that I have 2 girls? So probability is calculating the number of favorable outcomes divided by the total possible outcomes. All right, so I have 4 possible outcomes. I want a girl, so there is only 1 favorable outcome there. So the probability that you get 2 girls is 1/4. Same family. I'm going to have 2 babies. So my possibilities are boy, girl, boy, boy, girl. What is the probability that I have 2 girls if you know that at least one of the children is a girl? So I want the probability that I get 2 girls given at least one is a girl. So the numerator is your favorable outcome, which would be 2 girls. Your denominator is your total possible, which is at least 1 girl. All right, so when I look up here, they have a girl, they have a girl, they have a girl. So I have 3 possible outcomes with at least 1 girl. So that is my denominator. I want 2 girls, so there is only 1 favorable outcome there. So this probability is 1/3. The probability that you have 2 girls given the older child's a girl. So I have boy, girl, boy, boy, girl. I want the probability that I have 2 girls given the older one is a girl. So the numerator is my favorable outcome, which is 2 girls. The denominator is your total possible. All right, so given the older child is a girl, so I could have a girl and a boy or a girl and a girl. So I have 2 possible outcomes with a girl that is older. So that is my denominator. I have 2 possibles. I still want 2 girls. There's only one way that happens. So this probability is 1/2. Now we're going to do conditional probability with a 2-way table. So I have 250 patients who had knee, hip, and heart surgery. They were asked whether they were satisfied or dissatisfied. So when I look at it, for the knee people, I have some satisfied, some dissatisfied. I have 95 people that had hip surgery, knee surgery. I had 105 that had hip. There are 50 people that had heart surgery. Out of my 250 people, 210 are satisfied, only 40 are dissatisfied. This says if one person from the 250 is selected at random, determine the probability that the person was satisfied with the results of the surgery. So I want the probability that they are satisfied. So I'm going to write the number of satisfied people to the total. So I had a total of 250 patients, so that's my denominator. Right here, I have 210 satisfied people. So this probability reduces to 21/25. What's the probability they were satisfied with the results given they had knee surgery? So the two-way table actually makes things a whole lot easier. So given that they had knee surgery means that you could highlight that row, and now all I care about are the knee surgery patients. How many of the knee surgeries were satisfied? 75 out of the 95 were satisfied. So I can see that this answer is 75 out of 95, and that is going to reduce to 15/19. If we wanted to write it out like we had the other, I want the probability that they are satisfied given they had knee surgery. So the numerator is the intersection of satisfied and knee surgery, and the denominator is the number of people that had the knee surgery. And that's how we came up with 75/95. C says, what's the probability this person was satisfied with the results given they had hip surgery? Probability that they are satisfied given that they have hip surgery. So the numerator is the intersection of satisfied and hip surgery, and the denominator is the number of people that have hip surgery. All right, so given they had hip surgery means now we are restricting everything to that row. So I have 905 people that have hip surgery. So that's my denominator. I have 90 who had hip surgery and were satisfied with it. Sorry, there we go. And this reduces to 6/7. They had heart surgery given they were dissatisfied. The probability that they had heart surgery given that they're dissatisfied. So the numerator is the intersection of heart and dissatisfied, and the denominator is the number of people that are dissatisfied. So when I come up here, now, dissatisfied, there we go. Now we are talking about this column. So there are 40 people that are dissatisfied. That's my denominator. Heart surgery and dissatisfied. So there are 5 people there. 5/40, that reduces to 1/8. Thank you.